Welcome to the AI Research Roundup. I am Alex, and today we're looking at a paper from the Papers with Code trending list, published on the 25th of May, 2025. This work introduces the first framework that successfully trains vision language models to generate their own visual aids to solve problems. The paper is titled, VTool-R1, VLMs Learn to Think with Images via Reinforcement Learning on Multimodal Tool Use. So the big idea here is about how advanced AI models, specifically vision language models, which are AIs that understand both images and text, actually think. Right now, when they analyze an image, their reasoning is just a wall of text. This paper changes that. It introduces VTool-R1, a framework that uses reinforcement learning, basically a trial and error process with rewards, to teach these models how to use visual tools. This lets them create a multimodal chain of thought, a reasoning process that mixes text and new, intermediate images to find the answer. It's like giving the AI a scratchpad to think visually. And for those who want to try this out themselves, the authors have released the full implementation on GitHub. It's pretty comprehensive. You'll find all the code you need for training and evaluation, plus sample scripts and even links to the model weights to get you started. It's great to see such a complete release alongside the paper. Alright, so let's dig into how this VTool-R1 system actually works. The core of it is a process they call reinforcement from tool feedback, or RFT. This is a new training method. And this diagram shows the whole training pipeline, which they call Multimodal Grouped Reinforcement Policy Optimization. It all starts with a query on the left, a mix of text and images. This goes to the policy LLM, the model we're training. The model then performs two rollouts, which are essentially trial runs. In the second rollout, it gets the chance to use a visual tool, creating a new image to help its reasoning. After these rollouts, a reward model scores the final answers. These answers are also compared to a stable reference LLM using what's called the Kullback-Leibler divergence, which is a check to keep the training stable. Finally, these scores are used to calculate an advantage, a signal that tells the model not just if an answer was good, but how much better it was than its other attempts. This advantage is what tunes the model, teaching it to think visually. Okay, so now that we've seen the training process, let's look at a concrete example of VTool-R1 in action. This figure shows what's called a qualitative example, basically a real-world demonstration of how the model thinks. On the left, the user asks about a ratio in a bar chart. The model's first thought is to identify the key rows. Then, and this is the crucial step, it decides to use a tool. It runs a bit of code to generate a completely new image, which highlights just the men and women rows it needs. With this new focused image, its next thought is much easier. It just extracts the numbers and gives the correct final answer. This process really shows that visual scratchpad idea at work. And here's another example, this time showing how the model handles data presented in a table format. The task is to sum up all the earnings after the year 2006. So the model's first thought is to identify the year and earning columns and the specific rows it needs. Then, instead of just highlighting, it actually generates Python code, using functions to create a new cropped image that contains only those specific rows and columns. With this simplified view, it can easily extract the numbers, add them up, and get the correct final answer. So as we've seen in these examples, VTool-R1 doesn't just look at an image, it actively manipulates it. By using reinforcement learning to generate new, simplified images as a kind of visual scratchpad, the model can break down complex problems into much more manageable steps. This approach makes its thinking process not only more powerful, but also more transparent. It's a fascinating step toward AI that can actually show its work. That's all for this week's AI Research Roundup. Thanks for tuning in. I'm your host, Alex.